Across the black geometry of interstellar night, an object carves a trajectory so lucid that even its uncertainties seem intentional, a silver thread of motion taut between the equations we trust and the instincts that keep whispering there is more to know. We call it 3-eye Atlas, third of the interstellar visitors caught skulking through the inner sanctum of our star's dominion, and already the numbers are behaving like riddles. The eccentricity is above 1, a clean passport stamped by another sun. The hyperbolic excess speed is not shy about its origin, arriving with too much energy to be captured, departing with even more confidence than it came. Astronomers are rarely poets by choice, yet watch the language they adopt when the data refuses to sit still. The object sings, the light curve dances, the residuals groan. Under the cold discipline of milliarc seconds and error bars, something feels alive. Not in the biological sense, but in the sense that a trajectory can be an argument and a set of observations can be a reply. We met at first as a faint smear salted across background stars, a whisper in the Atlas survey stream demoted by software and then resurrected by a human pair of eyes that refused to ignore a peculiar speed. Designation followed. Then the call went out through the networked spine of modern astronomy. Point every optic that breathes, spin up the spectrographs, wake the photometry pipelines, ping the radar if geometry permits. As the hours turned, telescopes scattered from Mauna Kea to La Palma, from Paranal to Siding Spring, joined a choreography of follow-up that has become the heartbeat of contemporary discovery. And what a heartbeat it was! Whether you imagine this object as a wayward relic of planet formation, an ice-dark shard of a distant Kuiper belt, or a messenger built by hands we have not yet met, the significance is the same, the Milky Way. He is porous. Our solar system is not a sealed room, but a crossroads, and we are beginning to read the traffic. Each interstellar visitor is a syllabus in motion. Oumuamua gave us the taste for paradox. Borisov restored our faith in comets that behave like comets. 3 Atlas arrives like a question mark pressed into fresh snow, forcing us to step carefully and admit how much we don't yet understand. The measurements are spare and uncompromising. Astrometry pins the path with exquisite precision, every nightly arc sharpening the emergent solution for velocity and inclination. Its incoming speed, measured against the solar rest frame, rides in the neighborhood of tens of kilometers per second, a velocity that is both ordinary for the galaxy and unbound for our sun. The object's brightness breathes with rotation, rise, fall, rise again, sketching a light curve that hints at an elongated body or a contact binary, perhaps a lumpy shard spinning with a period that would be tedious if it weren't so informative. Spectroscopy reaches for the spectrum, groping through the signal-to-noise to harvest any hint of surface chemistry, a gentle red slope in the reflected sunlight perhaps, or faint absorption features that could betray organics, silicates, or processed ice. Observers argue over phase angles and thermal inertia. Models are thrown like nets into the sea of possibilities, a highly porous assemblage with a remarkable area-to-mass ratio, an icy core mantled by refractory dust that blanks the usual cometary flare, a brittle fragment whose surface, polished by cosmic rays across eons, spills only reluctant volatiles. Radar tries to nose in, but the geometry is merciless. We glimpse shape in the vaguest of silhouettes, and still the data speak. The hyperbolic fit is uncompromising. The sun will bend the path but never own it. Then the numbers begin to itch. The residuals, the small differences between what gravity alone predicts and what the telescope measures, show a hint of a whisper that should not be there. Not a shout like a rocket engine, not the exuberant jets of a boiling comet at perihelion, a whisper, a non-gravitational acceleration on the order of a few parts in a million of Earth gravity, persistent over days, as if sunlight is pushing more effectively than expected, or as if gas is leaving the surface without the courtesy of a tail. The effect is real enough to clear peer review, but coy enough to court argument. If it is outgassing, then where are the canonical signatures? Blue CN emission, the photometric coma, the photopolarimetric haze? If it is radiation pressure, then the area-to-mass ratio is large, implying either extreme porosity, a fractal snowflake of a body, or a geometry that spreads surface area with deceptive efficiency. The light curve refuses to settle the fight. The tumbling suggests shape. The brightness swing suggests albedo patches. Yet both interpretations can be tuned to support whichever hypothesis one prefers. In the end, when you press the equations, the object slides through the models like a fish through a net. Speculation is not a sin in science. It is a stage to be passed through with disappliques. Ni, on one end of the spectrum lies the comfort of nature, a shard from the cold nursery of a long-gone system, baked on its surfaces by cosmic rays into a tough rind that throttles the outgassing, allowing only shy jets from cracks and corners. Perhaps the volatiles are exotic, molecular hydrogen clathrates, nitrogen frost, carbon monoxide sublimation at temperatures too low for drama and too high for coma. On the other end lives engineered intent, a thin, mirror-bright membrane that drinks radiation pressure and converts it into a steady push, a composite honeycomb structure with a mass so meager that sunlight is effectively wind. Between them lies a land of intriguing middle ways, a natural object so porous it behaves like a sail, a cometary relic that mimics control because the geometry of its vents and the cadence of its spin conspire to produce a stable directional thrust. The discipline is to keep all these doors open without rushing through any. We have equations that honor conservation of momentum. We have telescopes that do not lie. We have our animal hunger to assign agency where none may exist. The trick, always the trick, is to let the sky be the author and ourselves the patient translators. Still, coincidences have a way of stacking up until even the cautious begin to tap their pens. The timing is painfully convenient. The object's perihelion and Earth's vantage align such that the best observational window arrives just as a patchwork of instruments enters maintenance cycles, just as a solar radio burst snarls a stretch of deep space telemetry, just as a handful of neutrino detectors around the world register a modest uptick in high-energy visitors from a direction close, but not exactly aligned, to the ecliptic path. No causal thread is claimed. None should be, not yet. But human pattern seeking is not a failing. It is the engine that built science in the first place. Correlation is not causation, we remind ourselves, while scribbling down every correlation we can find. A faint burst of soft X-rays near the time of a reported brightness surge, a brief geomagnetic wobble when the object traverses a region of heliospheric turbulence, the absence of a coma where standard thermal models predict a whisper of one. Every line we draw between dots is provisional, a chalk sketch that rain can erase, and yet how the mind loves a constellation. Strip away the romance, and orbital dynamics brings us back to first principles that never falter. The sun curls space-time into a well. The object arrives with energy sufficient to climb in and out without surrender. Its deflection angle is clean, a good student of Newton, altered by tiny contributions from Jupiter's distant handshake and the faint tug of our inner planets. The Tisserand parameter, computed against Jupiter, confirms the interloper's status. It doesn't live here. You can integrate the path forward and backward, sliding past uncertainties like a skater navigating imperfect ice. And still the conclusion holds. This is a drifter from the wider sea, not a child of our neighborhood. At perihelion, solar radiation and pressure matters, a small drumbeat on its sunward face. Yarkovsky effects are a stretch for a transient visitor, but not impossible if the spin state cooperates, heating one side more than the other and exhaling momentum as thermal photons. With each additional night of data, the covariance ellipse on the ephemeris tightens its belt. We can say where it will be next week within arc seconds. We can say what it cannot be with growing confidence. But we cannot yet banish the small accelerations that ride on top of gravity like foam riding a wave. Then comes the silence, the blackout that feels more like mood than physics, precisely because physics caused it. Solar conjunction is a merciless editor. Even the best observatories bow to glare. The object slides too near the sun's crown from our perspective, and for crucial hours the detectors must look away or risk saturating. Radio arrays pivot elsewhere as a solar storm throws static across the spectrum, and a network outage at one of the archival servers delays the release of a tranche of processed images by just enough time for rumor to outpace reason. In those compressed hours, the story grows teeth on line. The craft pivoted, the object winked, the agencies sat on data. When the images finally arrive, they are mundane in the way that science is often mundane. Usefully boring, productively consistent. You cannot argue with photons once they've been carefully corrected for bias, dark current, flats, and cosmic rays. And yet suspicion, once courted, is a house guest that refuses to leave. We have earned some of that mistrust. Institutions can be slow, and the frontier between swift transparency and careful verification is not always obvious to those of us enthralled by the chase. What then do we do with a mystery that refuses to collapse? We build better instruments. The Vera C. Rubin Observatory will soon rake the sky nightly with a scale and cadence that would have rendered the blackout less brutal. The European Space Agency's Comet Interceptor, already planning to loiter at L2 like a patient heron, could be joined by rapid response chasers, solar sails furled and waiting, small nuclear electric sprinters, even beamed energy craft that can pivot from the whisper of discovery to the sprint of intercept before the visitor is gone. We draft protocols that treat anomalous interstellar objects like both scientific targets and potential foreign embassies. We add words to our standard operating procedures that we never expected to write about etiquette in the presence of possible agency. We refine algorithms that sift light curves for signs of control, micro-variations that resist natural explanation, knowing full well that the false positives will be legion, but that the first true positive would be the most consequential line ever drawn by human beings. And we teach our students how to speak two dialects at once, the cool language of error bars and the fiery language of wonder. Beyond the laboratory and the launch pad, the implications touch us where we live, inside our private cosmologies. If 3i Atlas is a natural item wearing a cloak of peridot, yes, then the cosmos has just reminded us how inventive geology and ice can be when granted 1 billion years and 100 million collisions. The lesson is humility. Do not underestimate what nature can build and how it can move. If, in some future data set or daring intercept, we find signatures that nudge us across a line, regular thermal modulations that match a power budget, albedo patterns too rectilinear for comfort, thrust that remains steady through thermal transitions, then we will need vocabulary we haven't used outside of fiction. A probe needs a sender. A sail needs a captain or a caretaker. A messenger implies a message, even if the message is merely presence. That shift would be tectonic. It would reorder funding priorities, rewrite treaties, and more importantly, rearrange the furniture inside our heads. We would have neighbors, even if they are silent. We would be late to a party already in progress, and our first responsibility would be grace. Yet we should not discount the middle path, which is where science thrives. Unknown physics does not mean new physics. The universe often hides the familiar inside the strange. Perhaps the non-gravitational acceleration is the sum of events aligned by chance with a spin axis that precesses just so. Perhaps the surface has a veneer of ultra-low density regolith, a microlattice that couples to sunlight the way mist couples to wind. Perhaps the albedo map is patchy in a way that multiplies small effects into coherent push. If you step back far enough, a murmuration of starlings looks like a single organism with intention. Up close, it is a field of simple rules making emergent art. In the same way, a rolling bit of exo-debris could paint intent where none exists, and we are the ones who must remember the parable. There is romance even in that chastening answer. It would mean that the Milky Way is littered with artifacts of natural construction so varied that once in a while one flies like a thought. So where are we now? Balanced on the bright edge of enough information to be fascinated and not enough to be certain. The data split that stunned labs, a neat right-angle fracture in the community between Comet and Craft, will heal not by consensus but by accumulation. Every new observation compresses the space of possibility. Upcoming nights will pry the light curve wider. Thermal infrared will lean in for the heat that betrays mass and spin. Polarimetry will lift the grain of the surface like a thumb over paper. The black box of our ignorance is shrinking. Already the orbital solution draws a map to the outer dark, a bookmark slid between the pages of our local interstellar medium that we will return to with future telescopes, scanning for a ghostly trail, a filament of dust or plasma, footprints that would speak to composition or charge. If our radio eyes dare, we will comb the path for narrowband spikes, distorted reflections of our own transmissions, or the signature of a carrier wave. Caution will be our chaperone. Curiosity will be our engine. And then, inevitably, 3i Atlas will go. Past perihelion, past the slender leash of our best instruments, past the H of even our most optimistic chasers. We will be left with numbers and with the ache that attends every great question we cannot yet answer. But ache is not defeat. It is a signal, like redshift, like polarization, that points to the work to come. We will build archives and curricula and missions because of this thing. In the same way, a strange stone on a beach can catalyze a lifetime of geology. When the next interstellar traveler arrives, and it will, we will be faster. The interceptors will already be unfurling. The routing tables for public data will already be hardened against rumor's advantage. The young scientists watching this one slip away will be the principal investigators who catch the next one by the sleeve. The skies teach patience by giving us velocity. From the first caveman who looked up and tried to name a light, to the engineers who thread microwatts through vacuum, we have been practicing the same ritual. Notice, measure, argue, revise, repeat. Sometimes the ritual reveals that a comet is a comet. Sometimes it reveals that a comet is a mirror held up to our own longing. 3i Atlas could be either, and the revelation will be equally valuable. If it is nature, then nature has grown more interesting. If it is craft, then our grandchildren will be born into a cosmos that never again feels empty. In both outcomes, we win. We acquire not only facts, but posture, a way of standing in the universe that is both modest and daring, both skeptical and enchanted. So let this be our answer to the object that will not be owned by our gravity. We will not choose between romance and rigor. We will carry both like twin instruments in a single case. We will let equations calm us, and we will let wonder keep us awake. We will accept that blackout hours are part of the dance, that coincidences are not always conspiracies, that data splits do not mean that truth is broken, only that it is larger than the first model we tried to fit around it. When the visitor is gone, we will still be here, staring up, building, rehearsing contact protocols we may never use, and loving the sky for the questions it asks. And if one night, a century hence, a sail should slow at the edge of Neptune, and a language should light our receivers with grammar we can learn, it will be because we learned to listen in episodes like this, with our instruments tuned and our minds wide. Between gravity and intention lies a thin, shining road. 3i Atlas rides it, and we, for a while, ride along. We decode the light, we argue about the push, we tally the coincidences, and forgive the silences. Then we do what our species does best. We promise to be ready next time, and in making that promise, we make the next time possible. The universe remains a conversation even when it seems to be speaking in riddles. Our reply tonight is the work